and welcome to Precalc Lifeline. This is episode 1 and we will be discussing coterminal angles. So let's look at angles for a quick moment. All angles have an initial and a terminal side. And I'll denote this as I for initial and T for terminal. And angles, they're measured from their initial to their terminal side. And this is often denoted as theta, the Greek letter. And so let's look at the word coterminal for a second. Coterminal, within the word we can see terminal, right? And this is simply referring to the terminal side of an angle. And co means sharing. So angles that share a terminal side. How can this happen? Well, let's jump right into an example problem. Let's start with the angle 120 degrees. Let me draw my y and x-axis, and then all angles in standard position start with their initial side on the positive x-axis, like so. And then up here, we know we have 90 degrees, and over here we have 180 degrees. So 120 degrees falls in the second quadrant. Draw that. It's a positive 120 degrees. So how can we find a coterminal angle? Well, one way would be to add a rotation onto this terminal side. How can we do that? Well, it's easy when we look at it graphically. So we're going to go around a full 360 degrees, right? And then add on another 120 degrees to become coterminal with our initial 120 degrees. So this would be like the addition problem, 120 degrees plus 360 degrees. And this gets us a positive 480 degrees. So that's the methodology I like to call adding on rotations. Let's head over to the second example to see another methodology. So let's start with the angle 810 degrees. Draw my y and x-axis, and I know that 360 degrees is one rotation, so 720 degrees is two rotations. So I know that 840 degrees is more than two rotations. So let's draw that. One rotation, two rotations, and then I know up here is 810 degrees because I add on another 90 degrees to 720, and over here is 900 degrees. So I know that it again ends in the second quadrant. So let's draw that. Alright, so how can we find a coterminal angle? Well, if we were to add another 360 degrees onto it, that would be a really large angle. So let's try a new methodology. Let's take away degrees, or take away rotations from it. Well, how can we do that? Well, let's just simply look for this angle right here, taking away all of these rotations. How can we do that? Well, there are two different ways you can look at this problem. You could look at this problem like this is 90 degrees, and then from 810 to 840, this right here is another 30 degrees. So you could look at this as 30 degrees, and then so we have the simple problem of 90 degrees plus 30 degrees equals 120 degrees. And that's one way to find the coterminal angle. Another way would be to take the 840 degrees, and we know that it goes through two full rotations and then some, so we could subtract the 720 degrees, and we again get 120 degrees. So 120 degrees, either way you do it, is a coterminal angle of 840 degrees. Now, in some instances, you might get an angle that is too large to graph quickly. So we sort of have to think of those algebraically. So let's try an example like that. Let's start with the example of 5,400 degrees. Now, it would be sort of infeasible to start graphing all those rotations. So let's think about it algebraically. So we know that 360 degrees is one rotation. So let's think about it like this. Let's say, what's 10 rotations? So 10 rotations would be multiplying the 360 by 10, so we get 3,600 degrees is 10 rotation. So let's try by subtracting 10 rotations from this large angle. So let's try that. And we get 1,800 degrees. So now we know that we've gone 10 rotations around and we still have 1,800 degrees left. When I see that 180 and then another 0, I think 180 degrees. So 180 degrees is a half a rotation. So 1,800 degrees is 10 1/2 rotations. Another way to say that is 5 rotations. So let's see where that leaves us if we subtract. And as you can see, those are the same thing, so we're going to get 0. So we know that this went around 10 rotations and then another 5 rotations. So this is 15 rotations, and we end on the positive x-axis at 0 degrees, or we could think of this as 360, or even possibly 720 degrees. And then there's one more methodology that we can use in finding coterminal angles. And this is to go in the opposite direction of the original angle. So let's draw my x and y axis. Alright, so say we have the angle 120 degrees again. Right, we know that it's in the second quadrant. 120 degrees. But that's going in a positive direction. We could find a coterminal angle by going in the negative direction. And if we go in the negative direction, that means we go clockwise. So, let's try that. So let's just start by going, we'll have the same initial side. Let's just start by going a negative 180 degrees, right? So we know that 120 degrees, the 180 degree line is the same. So we have negative 180 or positive 180. So we know that 120 degrees in the positive direction is actually 60 degrees from that 180 degree line. So we know that we have to go a negative 180 degrees and then 60 more degrees to hit the 120 degree line in a positive direction and to be coterminal. So negative 180 degrees minus another 60 gets us negative 240 degrees. Make sure you don't forget this negative sign, because that is telling us the direction. And 240 degrees is not the same as 120 degrees. It's not coterminal. It's negative 240 degrees. And this methodology is especially great if we have a stipulation in the domain, such as like negative 360 degrees to positive 360 degrees. Find a coterminal angle within that, within one rotation negative and one rotation positive. So in our first example, we added 360 degrees and we got 480. So we can't do that if we have this stipulation. But this methodology fits in nicely within the restrictions. And that is why it's such a great way to find coterminal angles. Thank you so much for joining me on Precalc Lifeline today. If you want more help in the future, please subscribe.